morning, everyone. Thanks for joining us today. This is our Creating a 3D Holographic View of Your Data with Global Mapper and the Ada Platform webinar. This is part of the Blue Marble Geotalks. My name is Katrina Schweikert. I'm a product manager here at Blue Marble Geographics, and I'm joined today by a guest here, Keith Lay from Cleario Technologies, the Ada Platform. Good morning, Keith. How are you?
Good. Yourself?
I'm great, thanks.
I guess it's good morning, good afternoon, or good evening, depending on where people are coming from.
Yeah, absolutely. As always, I think we have people from all over the world, and it's an early morning start for you. Is that right?
Yeah, 7 a.m., but not too bad.
Well, we'll see if other people in your time zone have joined us this early. But I'm happy to have you here and hoping to bridge a couple of those time zones. Okay, so a couple of housekeeping things before we get started here. So as with our webinars, you are in listen-only mode, but you do have access to the questions panel. So you should see the questions panel there. Throughout the presentation, if you do have questions, we will be taking a look at those and asking those. We also have a couple of handouts that are included. One from the Ada platform, if you're interested in learning more about that technology, and also if you're not a Global Mapper user and you want to learn more about that platform, there's also a Global Mapper handout as well. We are recording this session, so we will be posting that. If you missed the live version or if you want to share it with your colleagues, we will be emailing out the recording. It usually takes a little while after the webinar to get that processed and uploaded, but by the end of the week, you'll have access to the recorded version of the webinar. Great. So today we're going to be talking about the Ada platform, which is a way to take your 3D data, maybe out of Global Mapper potentially with a nice export toolbar that has been added, and bring it into a holographic environment. So using augmented reality to look at your data. And I'll also be sharing a little bit about what you might do with that data to start with, how you can work with your data in Global Mapper to get it ready for 3D if that's part of what you also need to do. So I'm excited to look at these kind of two technologies and how they can play together. So if you're not familiar with Blue Marble Geographics, Global Mapper is a desktop GIS software. So it supports all types of different data, all kinds of analysis that we can do, as I'll show you kind of a brief overview. And then using the new extension that Ada has provided, we do have the ability to take that data out and bring it into this 3D holographic environment, which Keith is going to talk more about. So before we get started, I am going to ask a couple of questions. So a couple of polls here that I will launch. So the first one is, are you a Global Mapper user? And I'll just wait a couple minutes to see a couple answers on that. Just give that another minute. We've got, looks like a lot of users here, but maybe a couple that are new to the platform. Okay, let's go ahead and close that. So if you're curious about that, most of our attendees here are Global Mapper users. And a couple more questions here. Let's see, have you considered using virtual reality or augmented reality with your 3D data? So we're just trying to gauge a little bit of the interest here in working with this new 3D technology. Give that a minute to collect some more answers here. Great, so let's go ahead and close that one, and I will show those results. So it looks like a lot of people are kind of in the research stage of this, and a few people are pretty new to this technology. And then one last question that we have here before we kind of get into the meat of this presentation. What kind of 3D data are you working with? So, we see people using all types of 3D data. Obviously, Global Mapper does a lot with Lidar and photogrammetry and CAD data. And all of those technologies are accessible through this new holographic environment as well. So I'll give that just another couple seconds here. Looks like people are using a lot of different types of data, a lot of GIS data, but a lot of the more 3D heavy types of data as well. Great. Okay, so I'm going to start by talking a little bit about the kind of analysis that you can do in Global Mapper if you are brand new to the platform. I think most of you are Global Mapper users, but sometimes our Global Mapper users aren't always aware of all the things that you can do in the software. So Global Mapper is really well known for file format support. We support over 300 data formats, so including CAD data, a lot of specialized kind of engineering and scientific data formats, the full span of GIS specific formats. So all different types of raster, vector, and terrain data that you can use. But we also have a lot of analysis tools, including 3D visualization, as well as analysis. We're also really well known for our technical support, a pretty easy to use, low cost GIS solution. Just a little overview of some of the types of things that you can do, working with vector and CAD data. With raster data, we can look at image analysis, doing band math and visualizing, false color imagery, that type of analysis. We have all sorts of 3D and terrain analysis tools. With our add-on Lidar module, we can do automated point cloud classification, as well as editing and filtering. We also have a tool called the Pixels to Points tool that can take drone data, so usually series of images that are overlapping, and turn those into a photogrammetric output. So ortho images, 3D models, and 3D point clouds that you can use like Lidar. We also have tools for map design and thematic mapping. So this is kind of an extension of that, is what we'll do in Global Mapper today, is kind of prepping our data for a 3D presentation format to bring into the Ada platform. And we also have options for scripting and batch processing of data, so if you do want to automate your workflow. So I'm actually going to switch to Keith here, and you can tell us a little bit about an overview of the Ada platform.
All right, thank you very much. Yeah, so the Ada platform has been developed as a visualization tool to take the 3D data that you're already working with and place it into the space, take it off of the flat two-dimensional screen and actually place it into the space that you're working in as an actual three-dimensional hologram. And so this allows you to get much more insight on your data, to share and collaborate that data in a new way that wasn't possible before. And this is beneficial to both experts and engineers, as well as non-technical stakeholders as well. So we find that this is a very useful tool for sharing project data with stakeholder engagement groups, with review boards, with government officials, but also within the engineering world as well, to share data in a way that allows for really quick understanding of project specifics and geological realities. So as I mentioned, the stakeholder buy-in is a really important aspect to this, that allows non-technical people to really be able to immerse themselves in the 3D environment and actually gain understanding that would be very difficult for them to do in a way that if you're just presenting a flat printed map or a PowerPoint of that information. But it also allows people to visit locations that would be either physically impossible or extremely difficult or dangerous to visit otherwise. So this concept of using Global Mapper to manage your 3D spatial data and then using Ada to create that actual true digital twin is where we can see a lot of power in terms of bringing people to the actual site. So some of the applications that we've had success with in transportation and civil infrastructure, in the mining area and environmental engineering, energy, oil pipelines, construction, earthworks. So as mentioned, stakeholder engagement for public, investor, regulatory, or executive, giving project updates and onboarding for extended teams, technical expert engineering reviews, design team discussions. On site, it also has an operational advantage where you can actually, if you have a shift change on site of a project, you can put up a drone to do photogrammetry and then very quickly show people the 3D visualization. So you see here in some of these screen captures or shots that we have here, people are wearing the HoloLens headset. And the HoloLens headset from Microsoft is the tool that we use from a hardware perspective that actually allows us to take that 3D data that we've converted into the hologram with our software and literally project that as a realistic up to 1-to-1 scale hologram in a physical space. And not only does that, if you have a situation where multiple people are wearing the headsets in the same space, they're all seeing the same data located in the same physical space. So when you're interacting with it and when you're pointing to things, people see what you're actually pointing to. But it can also be done remotely. So we can also have people wearing the headsets in entirely different locations and all sharing the same data in a virtual environment. We've had over 40 projects that we've applied this to. This is quite new technology, as you can imagine, and quite new software, really just released this year. But we've actually seen quite a bit of success out of the gate with this, with a number of organizations that you might recognize here around the world that have used this product successfully to communicate technical 3D data to a variety of audiences. And some very specific ROI that we've seen from this. We actually are working with a very large mining reclamation project here in Canada, where I'm based. It's a $900 million project that requires many, many levels of stakeholder engagement and buy-in. They were having a lot of difficulty with that and trying to depict the subsurface technical information on this reclamation project. Ooh.
I think you're still okay. I might have stopped your camera there, but I think you're still okay on your slides.
Another ROI that is a very high value. We had a client that was dealing with a review board on a mining limit. That review board was not able to see the point of view of the client when we were able to put that onto the ADA platform and use the HoloLenses and create the 3D visualization of that. It actually changed the review board's decision, a $100 million benefit to that client. So this is very important from the perspective of being able to present information in a new way, in a more complete way to even technical audiences. So basically what the ADA platform does, it is not a tool for creating data. That's why we are so excited about our partnership with Global Mapper, because Global Mapper is of course the premier tool for georeferencing all of your spatial data and bringing all of your GIS, CAD, photogrammetry, Lidar, and subsurface data together. So what ADA does is it allows you through Global Mapper to bring that data together, put it into our ADA Cloud environment. And our software, which I'll show you how that works a little later on, will actually do the conversion of that automatically. If any of you have played with this stuff before, you might have worked in Unity or worked with some programmers that work in something like Unity. And of course, you might be familiar with that workflow in which you'd actually have to send your data to a team of programmers. They would have to work on it for any number of weeks. Of course, the data would change in the process of them doing that, and it would be a fairly cumbersome process. What we realized we needed to do, and what we have done, is we've created a data-driven drag and drop software tool. As I'll show you shortly here, you literally open up our cloud-based, Azure cloud-based tool in the browser. You create a scene and you drag and drop your export from Global Mapper into our tool, and that's it. We basically have taken the workflow that was previously maybe weeks down to literally minutes. As I mentioned, we've used the Azure Cloud as our tool for the processing, which gives a great deal of security. It's recognized as one of the best online security solutions for storing data. It also gives ubiquity. That means you can have authorized people that you've given access, the ability to access that data and view those 3D holograms from anywhere that they have an internet connection, and the password. But I've mentioned the Microsoft HoloLens. We're using the Microsoft HoloLens 2 now, which is the latest version of that hardware, which kind of gives the best experience in a mixed reality environment. But we can also go to iOS devices as well. So if you have an iPhone or an iPad, you can actually use that to actually project using the augmented reality tools within those devices. You can actually use that to project the 3D data, say, onto your desk or onto your table in your space. So the advantage that we bring to the marketplace, and there are a few companies that are sort of trying to put this together for you. Ada has some specific advantages, not the least of which the speed of processing. As I mentioned, we have a data-driven workflow that basically is just drag and drop. Our software developers have worked very hard on the clarity and visual fidelity of the data. So we have a custom viewer both on the HoloLens on iOS devices that renders at a very high rate of data and stability. We use spatial anchors so that georeferenced data can actually be anchored in a physical space. And so if you have multiple people actually looking at that data, it will actually look as if it's a permanent fixture in the room as you move around and interact with it. Security, as I mentioned, Azure Active Directory is a very secure environment. You can even have iris scanning as credentials for logging in. And the collaboration piece, which is critically important as well. So something I'll show you some examples of later on, in which you can either collaborate with multiple people in the same room, or you can also collaborate in remote locations and actually create a virtual meeting room within our environment where people can actually log in and all look at the same data from remote locations and interact with the data and speak with each other and hold a virtual meeting in a 3D space. So that's my presentation portion. We'll get into the demo portion now to kind of show you the workflow. But if you do have questions, you can email me directly. There's my email there, or you can check out more information later after the webinar at our website.
So before we move on to taking a look at the workflow in Global Mapper and then also in your platform, there is one question that came in that I thought you could address now, which is about whether it's limited to Azure, or if can you also provide support for AWS at all?
So we've partnered with Azure for a variety of reasons. It works very well with the HoloLens, obviously, both products from Microsoft, and we felt that was sort of the best in class in terms of security. Clients that we're working with, the security is critically important. The other advantage to Azure is that they localize in different markets. So here in Canada, as an example, we do a lot of work with government data, and by law, we actually cannot put that data on US-based servers. It has to be on Canadian-based servers. And so because Azure is localized in US, in Canada, in Europe, in Asian markets, we can take advantage of that. So we're not on the AWS, but as far as the user is concerned, it actually is completely seamless from them. You don't actually have to deploy this on anything. You just basically log into the cloud through your browser, and all of that backend stuff, you don't need to actually deploy that at all.
Great. Okay, so let's take a look at some of the data preparation that you can do inside of Global Mapper. So I know I had some screen sharing issues before. Hopefully it's working for everyone now and you can see my Global Mapper here. Um, so I have gone ahead and installed the extension that you'll need to do this direct export from Global Mapper into the right format for this platform. So I'll just show you quickly how to do that. So if I just go to help and open up the license manager, you can just add an extension. This extension you'll get directly from the ADA website. If you do want to go ahead and try making some of this data. So this is a subset of data that we're going to look at both in Global Mapper and then the same data inside of the platform. We'll also show you some other examples as well, but I believe this data is from some of your customers that you have already worked with. Is that correct, Keith? From the Bison data?
Yeah, I mean, this is publicly available data, so we obviously didn't want to share anything that was proprietary, but this does come from Bison Avalanche Control, who are looking at various avalanche historical data, as well as some avalanche routes within an area called Rogers Pass, which is a particularly mountainous region of the Rocky Mountains here in Canada.
Yeah, so I think this is part of Glacier National Park in Canada.
Yes.
And so I believe they have some monitoring towers. You can see these kind of yellow dots here. And they also have a number of kind of sensor locations where they have sensors going on. And then in pink, I have some of these avalanche areas. So this is kind of historical avalanche data. So within Global Mapper, I might have wanted to do some terrain analysis on this type of data. I could do some watershed analysis to create these sort of stream and water flow models. I might do some contouring or some volume calculation on different areas here. Any of that type of analysis that you want to do to kind of work with this data or do that analysis, or maybe do some planning if this is more of a site where you're doing construction or engineering projects. We can do all of that. Before we bring this data into Global Mapper, we do want to show you one thing that we're going to do to create some additional information in this. So because we are kind of working with, we almost want a kind of map layout type product here. It's quite common that people want a sort of a text box that describes what they're showing in their data, especially if you are coming from the engineering or surveying world. So in order to show that in the 3D environment, we're actually going to create a sort of 3D platform for that information to sit on and then bring that data in and give it a geospatial context. So that when we bring this into the augmented reality environment, we can actually see that reference data. So this might be, a legend or, that metadata about your data, about the project that you want to add onto the bottom of your data set here. So the first thing that I'm going to do is go ahead and bring in my data here. And I have just an image here. Actually, let's see if I can. I'm just going to bring in this JPEG image. So I've actually chosen to add this as a picture point. So there was a dialog option that gives me options. I can rectify this data to bring it in. In this case, by adding it as a picture point, I can actually place it in the geospatial location that I want and kind of fake the coordinates. So this is probably the easiest way to do this. So if I just select that picture point, I'm going to go ahead and place that image on the map. And I actually have put this in probably the incorrect location here. Let's go ahead and move this point back to my main data location here. So just a little bit off the edge of my data here. So I've added that image as a 3D point. And let's do that one more time. Now, if I want to go ahead and place that on the map, I can just put that title block right below my data here. So go ahead and place that whatever size I want. So this is just a little descriptive title for this data set. Getting a little bit of echo here.
Sorry, that
So
was
you can,
my apologies.
that's okay. That's okay. So we can go ahead and place this data. So you can see that this is just kind of a informational block that we've added, and this was just saved as an image. I'm going to place that into my scene here. So when I export into the Ada platform, it is going to be based on the terrain data, and I do want to give this kind of title block a height within the context of my data. So the last thing that I want to do here is to kind of create a little elevation platform that this data can sit on. So I'm going to just use my area feature tool here, and I just want to draw kind of the extent of where I want that platform to sit. And the one important thing that I want to do here is go ahead and give it a height. So I'm just looking at my kind of elevation legend right now and kind of looking at what ranges I have here. And I'm going to go ahead and put this kind of just below my data at 780 meters. And also we can go ahead and probably give this a solid white fill so that we can kind of see it as a nice white platform in 3D. This is really just a platform for our legend. And I'll go ahead and put that under my imagery here. So then the last step here is to just convert this to an elevation grid so that it actually has that elevation data to sit on. So I'm going to right click on that area feature and turn it into a flattened terrain grid. So because it already has that height attribute, it will know what height the terrain is supposed to be at within this area feature. And we will go ahead and create that terrain grid, and I'll just put that underneath the other data so we can nicely see our data there. One last step that I need to do here, this is a little bit maybe unexpected here, but because I do have sort of an irregular extent of my terrain data, I have some areas that are going to end up as no data, so kind of at the edge of my terrain. And I don't want the no data to be everything that's white, otherwise I'll kind of lose parts of my legend here. So the last step I'm going to do here is to actually change my background color. This will give us a better idea of what's actually being exported. So now I can see that, everything that's gray will just be, transparent within the 3D scene, and I will get a nice white text block here at the bottom that gives me some information about the scene for, whatever presentation we want to do with this data. So the last step here would be to go ahead and export this out. So this is really simple. I just need to, pick a folder, and I've already done that. And then it will go ahead and export the terrain data. It's going to include, all of this vector data that we have loaded. So we'll see the streams, we'll see these pink areas that I've made slightly transparent so we can see the terrain. And we'll also see that title block. So that's kind of the basic environment here. So I've gone ahead and already shared that data with Keith. And Keith, you can go ahead and show us how that might look within the platform.
Yes, like all good cooking shows, we've got one in the oven already. And we got my screen now?
Yes.
Excellent. So this is the cloud-based tool that users of the software would log into. And it's deceptively simple. I'm going to go through the workflow on my end, and kudos to Katrina, because she did the heavy lifting here today in terms of what Global Mapper is capable of doing. So as I mentioned, the Ada platform is really about the visualization piece. So we do have the one button export that you saw that basically collects the data into the correct formats and puts it all together in a folder. And you'll see that I have that here on my end. So we've got the 3D data, we have the color map, a few other files that come together. And so the way it works within Ada is we actually create a scene. And a scene is basically a snapshot of your 3D data that you can create a hologram out of. And so the way that works, on the right thing, is you basically take the export that you have from Global Mapper and drag and drop that into our system. There's a few fields to fill out. And if you did want to put in some information about the client or the status of the project or the project manager or what have you, you could add that in as well. But basically, once the entire workflow is dragging and dropping your export from Global Mapper and clicking the Create Scene button. And that's pretty much it. So as I say, what this normally would have been in the past is you would actually have to send this, figure out what the right export files were, and then send that off to some programmers that would use an environment like Unity or Unreal Engine or one of the other programming environments that are out there, and they would kind of go away for a number of days or weeks and build a custom presentation of that data that would then allow you to view that as a 3D hologram in any number of hardware environments. But what we've done is we've basically taken that entire process and we've turned it into a drag and drop process, and all of that computational work just happens automatically in the back end. And so that's basically creating a scene. And what we've got, excuse me, on top of that is the ability to then create presentations. So a presentation is like a slideshow of 3D holographic scenes. And within that, you can click on the Create a Presentation button, and you'll see down the left-hand side, here's all of the different scenes that have been created. And creating a presentation is basically, again, a matter of drag and drop. So, you know, I've got a variety of different scenes here. Let's say I want to do you know, something like, I've got some stuff from Yosemite here, so I literally can drag and drop those here and just build out a series of slides in a presentation. And the way that that this works is it basically allows you to collect a variety of different 3D data types and show different aspects of a project under one holographic presentation. And so if you can think that you would have, say, an orthomap or a GIS data overview of the project, then you had some Lidar, and you had some photogrammetry, perhaps you had some subsurface data, excuse me. You can basically build those scenes as individual scenes of your data, and then drag and drop those into a presentation. And then when you click Create Presentation, that is basically built and ready to go for you somewhere in there. As you can see, we've got a lot of sample data that we're working with. Excuse me 1 second. I had to clear my throat there. So that's the workflow in terms of going from the Global Mapper export into creating your 3D holographic scenes and presentations. What I want to do now is actually show you what that looks like on the HoloLens device. So we have to kind of recognize a certain irony here. I'm going to be viewing this as a 3D hologram here in my space using the HoloLens, but unfortunately you folks are going to see that as a two-dimensional screen capture of that. But what you're actually seeing here is the output from the HoloLens. I'll point that, oh, hi, there we are. Point that to myself.
Hello.
And so once I have the HoloLens on, you see that it projects this interface into my space. So I can click Start Session, and here's all of my stuff that's on the cloud. So once you've saved the presentations onto the cloud, it's there for you to use. And again, we have a lot.
Lots of demo data there.
Yes.
So I'm sure you'll show in a minute, Keith, but we do have a question about you know, how you can anchor this 3D scene sort of into your physical environment.
Yep, you just see it right
that's what
there.
you're just showing. Yep, awesome.
Yeah, so basically when I selected my presentation, it gave me that cube. I can do it again if we want.
I think that covered it. They're also asking about, if it can be viewed sort of life size, if you can walk around in it.
Yeah, so let me just grab it off the device here and show that again. So yeah, it basically gives you this cube that kind of floats in your space.
Mm-hmm.
And then when you have it where you want, you tap, and it basically just kind of unfolds into your space. And so you can see that this is actually now a holographic view of the data that we were looking at on your screen is now sitting in my space. And so to answer your other question here, you see we have the adjust button, and this allows me to do things like scale it. So this, as you see, I've made this quite large. One-to-one, it depends on the scale of the data that you're wanting to present. This is obviously a very large chunk of geography, so one-to-one would actually be very tricky to do with something this large. But for an example, with a photogrammetry scene, let's say if you're actually doing a section of a site, you're wanting to show a particular detail of something that's being built or something that is a problem, and you basically want to do that as one-to-one, that would actually be more realistic. So one of the things that's a little bit tricky is just on the 2D representation of that, take that down, it can look a little bit washed out on your screen. And I think we had some different views here of this. And we're also seeing those overlays, those avalanche route overlays that you brought up. That data is in there as well. So I just wanted to show some other examples while we're here. So here's again some GIS data. What I'm going to do, I'm just going to turn off the background camera so that it's a little clearer for you to see what I'm looking at. There we go. Here we are with some overlays.
Can you make that full screen again for us?
Oh, sure. Sorry about that.
That's okay.
So here's some photogrammetry. So this is some drone photogrammetry from an open pit environment. Again, I can adjust that. We bring that around to create some different perspective. So we can really see how, we can get in and view that from a variety of different angles. If I was on a remote collaboration session, we would be having a conversation. You can actually see what I'm pointing at, right? You can actually see where my, you can see where I have sort of what we call it laser hands, where there's a little laser that comes out of my finger and you can see what I'm referring to. Here we have an example of some subsurface. Let me just bring this up so we can see that. So here we are viewing some borehole data. So you see I've got a legend there. So in terms of the boreholes, we can actually color code that in terms of the actual strata of the different materials. And then I also have some CVT data. So you can actually see that we can create a 3D representation of the cone penetration test data. And this is actually really useful for the subsurface. If you work with any of this borehole or SPT or CPD data, you'll know that when you're just looking at those large tables of numbers, those big, basically CSV or Excel files, they can be very difficult to interpret. And with our system, the fact that you have the ability to actually not only represent that as a 3D environment, but also georeference it. As you can see, I've kind of got an ortho map above that's showing what we're referencing to, this highway crossing. That we have the ability to really find a much more powerful way to actually show that subsurface data.
Mm-hmm. So one question that we had here that might be applicable to this data, are some of these elements dynamic? Can you turn on and off, some of maybe part of the borehole visualization? Kind of choose what you're showing within the scene?
You have some, I do have some checkboxes here in my legend where I can turn things on and off. Mm-hmm. So a little bit of an insight to our upcoming release that'll be coming at the end of this quarter is we're adding annotation tools, which will actually take this to an even greater level, where you'll actually be able to draw lines. So here, you can see I can point at this, and it actually gives me information about this strata in terms of the depth that I'm pointing at and what the lithology is and what the depth, the sample at beginning and end depth was. The version that we're working on for next release will actually allow me to draw connections between the strata and start to actually do design work within this as well.
So we have a couple of questions about borehole data that are being asked. So when you created the scene, there was a setting about the borehole vertical exaggeration. Is that just descriptive, or is that something that affects the scene?
So with that, there's going to be various different types of borehole information depending on the source of it. Oh, there's my other model. It's way up there. And so our software just allows you to put in some numerical information that allows you to describe how that data was captured, and just to make sure that it is displaying correctly.
Mm-hmm. And another question, is that borehole data, are you bringing that in directly from sort of the raw format, or was that created in another software first to show that borehole visualization?
We can actually ingest the raw data CSV files. So if you have that borehole data as tabular data, we can ingest that directly.
Great.
So we're looking at another photogrammetry model here. So this is actually from a location in Italy, one of our partners there. And this is a very active slide area. They don't like to send engineers into this area because it's actually quite dangerous. So by using the drone photogrammetry, they're able to actually create this 3D model. But again, instead of just looking at that on their flat 2D screen, they're able to collaborate and send people to this site. And of course, because drones are so ubiquitous and inexpensive now, they can actually do updates on this even on a daily basis to monitor without actually having to go to the site.
So we have a couple questions about kind of the sharing aspect of this platform.
Yeah.
How many different headsets can you have hooked up to this scene? Can you use the VR headsets and the iOS view simultaneously?
Absolutely. So I've got a little video here because again, it's just me today. So I'm gonna show a canned version of that. But here's how that looks. First of all, so in what we have is we basically create a virtual room, that everyone enters, and so you see the data is anchored there. Everyone has their own version of the 3D data in their space, but it's all anchored in relationship to each other. And so as we see, each person that's participating in the session has an avatar, and that avatar is georeferenced to where their location is related to the data in their space. And then as people point to things, we actually see what they're pointing to. Everyone can kind of see their hand position and what they're talking about. And we can also communicate through the system as well. So we use spatial audio. So as you're talking to other people, if they're on your right-hand side, you hear them on the right. If they're on the left, you hear them on the left. So it's amazing how quickly you get into a feel that you're all actually in the same room. This particular project, Denali National Park in Alaska, this was a review board. There was a dozen engineers that needed to review this project to move forward on this highway realignment in Denali National Park. And due to COVID, they just weren't able to do it. They weren't able to fly people to the site. They weren't able to gather. And so we shipped out HoloLenses to these dozen different engineers. They were located all around North America. They put on the HoloLenses and joined the session at a predetermined time, and they were literally all on site having a meeting. And so the remote collaboration piece is a really important piece to this. We've tested this with up to 20 different users with no problem. There is no theoretical limit. It would probably be more based on the bandwidth of people's internet connections, but we've tested this up to 20 different people, and yes, that can be a combination of iOS devices and HoloLens devices. We're also working on developing for the Oculus Quest 2. So if those of you who want to have a more affordable headset option, we're going to have support for Oculus Quest 2 coming up here pretty quick as well.
And can you talk a little bit about how that iOS part of it works? Does that integrate into the same kind of scene with other people?
Yeah, so basically, there's a couple of limitations. The iOS users don't have hand gestures because you do need the HoloLens to actually have the hand tracking. So what you see here, where you see the person's hand is and actually what they're pointing at, that does require the HoloLens, because the HoloLens does have the hand tracking. So the iOS participants wouldn't have that. But the iOS participants can communicate, talk and listen through their device. They'll see the other avatars. They'll be seen as kind of a little iPad avatar by the others as they move around. So it's pretty seamless for all concerned, with the exception of the hand tracking.
And a question about the HoloLenses, or maybe the new headsets that you're also talking about. Are those wired to the computer, or are they wireless?
So the brilliant thing about the HoloLens is that you're basically wearing the entire computer and display device on your head. So you don't have to be, there's some distinct advantages to it. First of all, you don't have to be tethered to any computer. So you're free to roam around and look at the data from all different angles within your space. And because it's what we refer to as mixed reality, that is, you see the room that you're in as well as the data projected in that room. So you also feel comfortable moving around. You don't feel like you're going to trip over a chair or run into the table or fall down the stairs, because you're not cut off from the world. You see the 3D holographic data as well as the space at the same time. The iOS, of course, is a standalone device. But the other advantage to the HoloLens is there's no setup. So for non-technical people, they literally turn on the device, put it on their head, air tap with the finger to launch the viewer, and then find the presentation and launch that, and they're good to go. They don't need to configure their video card on their computer. They don't need to figure out cabling. They don't need to figure out drivers. They just it's all very plug and play. Similar thing with the Oculus Quest, if you're familiar with that. That's the new standalone headset from Facebook Oculus. that works in a similar way. Again, it's a standalone thing that just sits on your head without cables.
Yeah, I certainly know the VR experience can be a little disorienting. So yeah, the idea of augmented reality is still knowing your context. I think I can understand why that's easier for people to grasp.
For sure.
I'm just taking a look at some of the other questions that have come in here. One question that I don't know if you have any thoughts about are what are the possible applications of this technology in defense and military?
So it's, we're quite industry agnostic in terms of we're there to create a 3D holographic visualization of the 3D data that you're working with already. So if you have 3D data that is, could be CAD data of different models of equipment, it could be some sort of geographical space that you're wanting to depict. It could be a relationship between the physical Earth and some structures that are being built. So the applications for defense and military would be no different from the applications from earth science or construction or oil and gas. We are the ability to take the 3D data that you're working with already and create that holographic visualization, and then be able to share that either in the same space or remotely.
On the same note, a question about bathymetry and bathymetric data. So I imagine that would be a similar setup in terms of being able to share that 3D data.
Yeah, absolutely. We actually have some projects. See if I can bring them up if we have time here. But we have some projects that are showing bathymetry, seismic, and resistivity for subsurface or subaquatic. Is that the correct term? I'm going to say so.
Or bathymetric, yeah, sure.
I'm just going to see if I can bring something up here. I need to switch back here.
So while that's loading, another question that was asked is about, excuse me, tying this model to a geospatial location. A lot of what we've seen in some of this augmented reality technology is, maybe looking at subsurface infrastructure when you're actually at that location. Does this platform have that ability to kind of be tied to where you are physically and put yourself in the model within that context, or use GPS information?
Yeah, so we use something called Azure Spatial Anchors, which allows the data to be anchored in one particular location. And this can be done on site as well, if I'm understanding the question correctly. But we can actually attach a barcode to a physical place, and you can actually point the HoloLens at that physical place, and and it will recognize the barcode, and it will recognize where you are, and then it can actually geolocate the data to that physical space. So we've had some examples where we can actually overlay our holographic data over an actual real place, like say, a mine site or what have you.
Mm-hmm.
So here's just some example of some of the underwater data. So we've got some borehole, and we have some bathymetry, and we've got some seismic data, and it's all georeferenced on Earth on map above.
So there's one question about a raster draped on the digital elevation model and whether that shows in the holographic image. I think you have some of that right here. So that is certainly something that you can do both from the global mapper export, and also you've probably created these models some other ways as well.
Yeah, so the raster, I mean, if you don't have it, so Lidar as an example is something that tends to not have a texture for it. And so in those situations, we provide our own lighting. But the best situation, of course, is to add the, in terms of your export, whether it be from your photogrammetry or whether it be from your from Global Mapper, is to have that raster overlay so that it can kind of really give that texture and information.
Great. So a couple last questions here. We are reaching towards the top of the hour. So can you talk a little bit about how this platform is priced? And we also have some questions about educational pricing or classroom use.
Yeah, so I'll just kind of go through some additional scenes while I'm talking, just to kind of see some stuff. This is actually a subsurface of a mine, showing all of the stopes and drifts and shafts. So basically, we price our software similar to other software that you would use, like Global Mapper or AutoCAD or what have you. And it's per seat per year. Just having a look at what we call an immersive scene. This is a little bit of a different environment where we can actually place people on the ground. This is a true one-to-one representation of an environment, so we can actually see that there's an engineering solution in the distance, and a creek and trees and what have you.
Yeah, that's nice. I know we have a lot of Global Mapper users that do a lot of planning, so I can imagine that being really useful for the kind of planning scenario.
For sure. So the pricing is basically $2,000 per user per year. And the academic pricing does exist, which is basically 50% off of the retail pricing. Here we're seeing some additional subsurface data here. We actually have a pipeline that is going underneath a river crossing. We actually have two different IoT measurements of that pipeline showing us change in depth of cover and location of that pipeline. And here's another example of kind of on-site photogrammetry. So this was literally shot. So that basically they dug a trench to actually view a fault. This is in the Grand Teton Mountains. Of course, if you do any trench work, you know that you can't leave the trench just open like that. So what they did after they did their measurements, before filling it back in, they actually just took their phone out of their pocket and just literally shot a series of images inside the trench, and stitched that together as a photogrammetry model, and then brought that into our software. And so here's an example where we can adjust and we can make this basically up to a 1-to-1 scale. So in this situation, you can actually do it in a way that it's as if you're standing in that trench that no longer exists.
And this one looks like it's sort of a cross-sectional view of the data. We did have a question about that, cross-sections.
Yeah, in this particular case, it's because the engineers stood in the trench and only shot one side of it. They didn't cross their mind to actually turn around and shoot the other side. So that's why we only have the half. But one of the annotation tools that we'll be releasing later this year will allow you to slice through data. We're actually working with some flat 4D data, which is, if you're familiar with that, it's a very cool representation of the effects of the ground that you're working with, and we creating a slicing tool that will allow you to see the cross sections of that flat 4D, but it would also work with any other sort of solid surface 3D model that you have.
Great. Well, it looks like we've reached the top of the hour. I know you have all sorts of demo scenes that you
Yeah.
might want to show. But again, if people have additional questions, maybe if you want to show that last slide of yours again, some contact information that people can reach out to you. And we'll also be sending, a follow-up email that has some of that information as well. So thank you so much for joining me today, Keith.
Thank you. That was fantastic. And again, we're really excited about working with Global Mapper and that integration. But yeah, please check out adaplatform.io or drop me a line at this email address.
All right. Thank you very much.
Bye-bye.